We're just going to do a diagnostics on the DPFs, and one of the best places to start off with, if you can't get a reading on the scan tool, or even if you can get a reading on the scan tool, you need to be able to confirm it. How we go about that is actually locating the differential pressure switch above where Trev's hands are there, and he's just trying to get the rubber hose off at the moment. And all we're going to do is actually going to tee in our gauge, and the gauge is going to go into the pressure side. Now the pressure side is just before the DPF, which is down around about here. It's actually one of the easy ways to tell if a vehicle's got a DPF is actually locate the differential pressure sensor. This one here, the rear, is a rear sensor. Okay, it was actually, the sensor's here, but the pipe actually goes to the rear section of the DPF, and this one goes to the front of the DPF, the engine side. When you're looking for a restriction, that's where the higher pressure is going to be on the restriction, if there's a restriction. But even under normal running, at idle, no greater than 1 kPa. No load cruising, you should be looking at no greater than 6 kPa. And under load, you should be looking at no greater than 20 kPa. So if the scan tool is plugged in, and what it's doing is actually reading off the differential pressure sensor, what I like to do is actually tee in an analog gauge to see what the real reading is, because these sensors can become blocked up with carbon, water, soot, combination, everything like that, heat. Where it's mounted on some of the engines can be extremely hot and has been known to damage the sensor. So you want to look at real, actual, true figures from an analog gauge will give you a real result. So we're over 10 kPa, so it is saying that it actually is restricted. On the sensor itself, we're only getting 7 kPa. So we're seeing a problem there. The sensor's reading low, which means that it's going to read it low. It's not going to want to put it in a regen, but if it becomes too blocked, it doesn't think it needs to be a regen. So what we're doing here is the passive regen driving is a more suitable regeneration mode. Some scan tools allow you to do it. Some scan tools do it stationary. We don't find that's a safe presetting to do it in, so we need to sit on a speed of about 75-80 k's an hour, keep the revs around about 2,500 RPM, and ideally the temperature, the hotter the temperature the better. How we got to this stage though is we actually had to clear the fault code. To clear the fault code, we actually had to readapt. We had to tell a lie. So of course this is only for testing, for training purposes only. The end result will be that this sensor was showing an incorrect pressure reading, so we're going to have to replace the sensor. We're going to have to send the DPF away for a proper clean and also a proper test to confirm the DPF hasn't failed inside. So by lying to it, the vehicle allows it to go back into normal drive mode, out of limp mode, and this will be able to determine, can we get the pressure down by doing a passive regen? If not, again, it's for test purposes only. If you can get the blockage down, that's great, but if you have to lie to it, that's not fixing the problem. You've just put a band-aid on it. It's a temporary fix, and it will fail the DPF big time, to a point where it actually might melt internal components such as the DPF and the turbo and the engine, failing its end result. So currently we're doing what I refer to as a passive regen. So we can hold it around about 2,000 to 2,500 RPM, about 80 k's an hour. So we need to hold it constantly for 20 minutes. And the idea is not to stab on the pedal too much off and on. Definitely an improvement on the pressure gauge itself. So it appears we have been able to clear some of the DPF out. The sensors all over the shop. It's like fluctuating from 14 to 8. The gauge is reading around about maybe 4. We're cruising there about 4 kPa. Scan tool fluctuating from 4 up to 9. There's something not right with it, yeah. That sensor's not good.